Okay, so let's talk about XML DOM and Java. So here's an XML document that lists several students. Notice that there's a meta tag at the top that describes the version of this document, some meta information about the document itself, what version of XML it is, and that it doesn't depend on any other documents. So there's no validation, there's no schema that this is being validated against. So it's just an XML document all by itself, and it has one root element students, and under there we have multiple elements under there, right? We have one student instance and another student instance, both with their unique identifiers ID 123 and ID 234, with Alice and Bob in there. Yes. Now to read this into XML. There's quite a few libraries out there, and we're just going to look at just a few of them, the more common ones, right? So let's just look at really quick some of the relevant classes that we need for parsing an XML document into a program. So here's some of the libraries and some of the packages that we're going to be using. They're all under javax.xml. So these are interfaces that are used by the Java language to build a document instance model in RAM. Also, we have several libraries in here that are implemented or defined by W3C, who's the body responsible for the standard, for the XML standard. Also, we have file because we're going to be reading an XML file from the file system. So first, we're going to be catching any exceptions because we need to write. We need to read from the file system. We need to all these factories might throw exceptions. And here's an example on first creating an instance, getting an instance of the document builder factory. And then creating a new instance of the document builder. And document builder allows you to both parse and then write XML, read and write. In this particular case, we're going to be just parsing the XML document from the file system. So here's a file. We parse it, and this gives you the root elements to the document, right? So that you can then manipulate it. You can alternatively call normalize. Normalize makes sure that any leading spaces, tabs, or white spaces are removed, right? That are unnecessary, and just cleans up the document for optimal manipulation. Once you've done that, you can start from the doc. You can start actually retrieving each one individual element. Okay, you can ask for the document element. We'll give you the root element. In this case, is the students, right? The top level root element, and you can get a node. Each the XML document, if you remember, kind of is represented like an inverted tree where you have the root and you have all these branches and leaves that are hanging off of the root and the branches. So everything is a node, but there are different types of node. There are text nodes. There are attribute nodes, there are element nodes. There are many different nodes that are represented in that document. Not just each element, but each element it might have attributes. Each one of those attributes are also a node in this tree. And any text that you might have embedded in there is also considered to be a node. So in this particular case, we get the here we're getting the root elements, and then we're getting the node name. The node name. It would be either the attribute name or it would be the element name. In this case, it would be the root's element node name, which is just a students. So once you have that, from the document, from the root elements, you can also ask for different elements in the document, the DOM, that meet a particular criteria. In this particular case, we're using the function getElements by tag name, meaning retrieve for me all the elements whose tag name is student, regardless of where they are in the document. Right? They could be at the top level, they could be nested one inside of another. Just retrieve them for me, regardless of where they are in the document. Okay, and this is going to return a node list, right? Which is going to be a reference to all these elements in the node tree. So this is going to recursively it's going to walk the entire tree, right? Doing depth first search, right? Looking for all the nodes out there that match the tag name equal to student, right? And this is going to give you a reference to all those nodes, right? And then you can quickly just iterate over them and then either change information or ask and query any other information about them. In this particular case, we're just going to iterate over the list of nodes and using .item, right? So you can use random access like an array, and you can get each node one at a time. You can ask some information about it, saying, what are you? Are you an attribute? Are you text? Are you an element? What are you? So we can ask each node, what type is it? And it'll come back with a short that can be compared with a static value. Whether are you an element node? Are you an attribute node? What are you? And here we say, if you're an element, I'm going to cast you to an element node so that I can now treat you as an element node. Okay. So once you are an element, I can ask for things such as attributes. If you're an element, you might have attributes. If you're an attribute, you cannot have attributes, right? Only element nodes can have attributes, right? So if you're an element, then now I can ask for attributes, a particular attribute called ID in that element node, and then I can then, starting from that element, I can then navigate to my child elements. I say, well, start looking at this element. Are there any elements underneath me, under my subtree, that might have a particular criteria? Here, from the student, I can ask, now give me all the elements whose tag name is first name. Notice that it would have made no sense to up here ask for, from the doc, get elements by tag name, first name, right? It would have retrieved all the first name elements, right, regardless of where they were, regardless of who the student was, right? And there would be no way for us to know that this particular first name belongs to this particular student, right? Because I would get a list of all of them, regardless of, without the context of where, who the parent student was. Yes. So instead, here the way we did it is we first get the student element, and then from there in that subtree we can ask about elements underneath that particular parent. Yes. So here we're asking for the first name, last name, and username. So this retrieves first name. Item 0 is a text. So this element name, this element tag only has a text node underneath of it, right? So here we're getting the first child. Okay, the first child under the tag first name, which happens to be a text node, right? We know because the original XML document, notice that first name, it just has a text in there, right? It doesn't have anything else. It doesn't have any sub elements in there, any attributes, nothing, right? It only has a text element. So here we're exploiting the fact that I know that you only have a text element, a text node under there, and then I can cast you. I can cast it to an element and then get the text content, parse it, and then retrieve it as a string, and then just print it out. Right. So here we're just walking the tree and just printing out the first name, last name, and username of all the students in that XML document. Yes. Now this is a little bit too low level, right? Of just walking the tree, right? It's way too close to the nitty-gritty of manipulating a tree. It's way too low level. So ideally, we would have a much higher level of abstraction, and we could treat this as actual objects. Right? This is way too cognizant of the fact that this is an XML document. Right? Instead, I would like to have a higher level of abstraction, just like we created DAOs, right, to kind of abstract the fact that these things is stored in a relational database, right, we provided an object model, right, so that when we iterated over several rows, we went through the result sets and the statements and the connections, right, but we populated instances of objects, and then we return a list of objects, yes? So we would like something similar here, something that is a higher level of abstraction. So here's a let's try real quick for movies.xml. So let me just so this is where we were playing around last week with DAOs. So let me just make some space here. Let's do some XML. So let's see. Let's do it under here. We'll say new Java class. And this will be under com, JJ, maybe lectures on XML. And then we'll have here maybe parse. And we'll do movies, XML, DAO. Yeah, let's call it that. And here maybe we would like to be able to implement here something like public void parse XML file. And here might be string XML file name. All right. And here we will maybe instantiate. Maybe we would want this to be maybe a singleton. So this might be private static movies XML DAO. And maybe here privates movies XML DAO. And maybe get an instance here. Did I spell it right? Illegal modifier and constructor, only public, protected, and private. Really?
You didn't name the thing above it. It's very confused.
What did I not name?
Private static. Then you have the type and you have no name.
Oh, sorry. Okay, instance. Thank you. All right. So this might be public static. Movies XML DAO get instance, and this might be if instance is null, then we're just gonna say instance equal new movies DAO, and then return the instance. Okay, so from let me close this. Jeez. Oh my goodness. So here we can get a hold of that movie DAO. So movies XML DAO. There we go. XML DAO. This would be movies XML DAO dot get instance. There we go. Now we have the DAO. Let's play around and put the XML document right here. And what do we call it here? What do we call it? Movies.xml. So let's create this XML document right there. We'll say new other. Let's XML file, and this would be movies XML. And in there, we'll paste this XML document. Okay. All right. So we can now from within here we can pass in the name of that file that we want to parse. So let's see, parse XML document, and we'll call it movies .xml. And so that file actually lives under movies.xml, under that package, under source. So maybe we'll need a location for a base directory structure of where those XML documents. So this would be base directory, and this might be under source, under com. On the source, so it's a source main Java com JGA slash lectures slash XML slash, that's it. Okay. All right. So this might be we would like to be able to do what in here? Let's see. We would like to be able to create a directory, a document builder. So let's create that, and we'll need to maybe we'll need to import this class. So let's import it. There it is, and notice that it's in JavaX parsers. Then we'll need to create a builder, and we'll need to import that as well. And here, I think it wants to throw an exception, so we're going to wrap it in a try-catch block. There we go. And it's going to open up the file, the XML file, and the file will be, oh, this wants to, okay, let's import that as well. And, all right, so, and the location will be what? Will be the base directory. Plus the file name that we pass in as argument. Yes? All right, so that's going to open it up. Once we have that, we can then just parse it. And let's import that as well. The one under org w3c, careful, not under swing. And this might throw an exception, so we need to add to the catch clause. There we go. And let's normalize it. Let's normalize it, okay. And then just get a hold of the top level document elements. And then just print it. There we go. All right, so let's run this. Let's run this guy. Hopefully this doesn't blow up. Okay, there. All right, so we got lucky. All right, so we got movies that was loaded from that XML document. So let's add a couple more things in here. Let's grab the list of all the movies. Let's grab all the movies. There we go. We need to import node lists. Wait, did I load the right one? Did I import the right one? Yes, looks like we did. And then we're just going to iterate over it. So let's grab and let's copy this. And let's just paste it in there. And we'll need to import node. Import node. And we'll need to import elements. Let's import elements. There it is. Once we have the movie, we can then cast it. We did cast it, and now we can retrieve all the children under there, right? Let's see. We can grab the IMDb, the tag, the title, the plot, and the poster under here. Oops, not there. There we go. And once we have that, we can just print it. Let's just print that. Let's paste it in there. Title node, node. Rename title node. Wait, did I misspell it? Oh, did I paste it twice? Ah! Oh wait, did I not copy this? Okay, there we go. All right, so let's try it out. Let's run this again. there we go. So it was able to grab Blade Runner and Blade Runner 2049. And if you haven't seen 2049, go out and rent it out tonight. It'll be in the exam. All right, so there we go. We were able to be able to just parse that. Typically, what you might want to do is that as you're iterating over it, you're instantiating a new movie object. You're filling up that movie object. You're adding it to a list, right, and then returning a list of movie objects, right. So this is very, very low level. Right? This is like us interacting with a SQL database using just SQL, right, and which soon we will stop interacting with a database using SQL. Instead, we're going to introduce next week when we come back from the break. We'll introduce a higher level of abstraction on how to interact with databases such as JPA and object relational mapping libraries, Hibernate and whatnot. Okay, but for now, let's do it with XML. All right, so let's now look at a higher level of abstraction using JAX-B.